Hello. This lecture will cover pages 102 through 104 of my lecture notes. Please print those pages out and have them in front of you as I present this lecture on additional analysis techniques, Chapter 5b, Superposition. We've been using superposition over the last chapter. We've discussed it, and I said that we'll talk more about it in detail in the next chapter, and here we are. We're going to discuss superposition and how to use it as an analysis technique. This technique requires no special mathematics and can only be done on paper. You'll see why in a minute. Superposition states that the current through or voltage across any element in a linear bilateral network is equal to the algebraic sum of the currents or voltages by each source. To consider the effects of each source independently requires reducing the other source or sources to a zero value. Well, how do you do that? To remove a voltage source, you short circuit it because its effect has to be equal to 0 volts. V equals 0 volts. So you have to short it. Though you can't do that in the lab, but you do it on paper. To remove a current source, you open circuit it because its effect has to be equal to 0. The current has to be equal to 0 amps. So you open it up. So what you have to remember as you go through the superposition analysis is you treat one source at a time to find a given parameter. And you have to reduce the other source or sources to 0. If it's a voltage source, you short it. And if it's a current source, you open it. And remember, you can only do this on paper. Here's a first example. Here's a simple circuit that has a current source here and has a voltage source out here. And I want you to find V1 across that resistor right there. Now, I want you to do this by using superposition. And you can obviously look at this circuit from the techniques that we've discussed for the past 4 or 5 weeks now, and you could say there's 2 amps flowing in this circuit. This has nothing to do with it. There's 2 amps flowing in that loop. That's what that tells you. If you have 2 amps flowing through 15 ohms, you have 30 volts across that, plus to minus. There's your answer. V1 is 30 volts plus to minus from here to here. But I want you to calculate that answer by using superposition as a technique. I want you to go ahead and try that on your own. Stop the video and I want you to try it. And I want to see if you got the same solution I'm going to get here. Because the way I'd work this problem is this way. I would first consider this 2 amp source. And here's my resistor. And here's my voltage source. And what I have to do to that voltage source is reduce it to 0. How do you reduce this 40 volts out here to 0? You short it. And I want you to find the voltage drop, plus to minus here, which we're calling V1. But it's V1 prime. It's not the actual answer, V1. It's going to be V1 prime because we're considering this source here. So I would say V1 prime, due to the 2 amp source, is equal to 2 times 15 equals 30 volts plus to minus. Now what I have to do, that's not the final answer. At least in the analysis it's not. Because what you need to do is you need to go back here and you need to consider what that current is, what that voltage drop is there whenever you have a 40 volt source and you reduce this to 0. So the second part of this problem is you put in your 40 volt source plus to minus, put in your resistor here, and out at this point How do you reduce that current source to 0? Well, you open it up. You don't short it. You shorted the voltage source to reduce this to 0. But how do you reduce the current to 0? You open it. So, V1 double prime, because this is our second calculation now. This was our first calculation. We get V1 prime due to the 2 amp. Down here it's V1 double prime due to the 40 volt. It's equal to, that's an open circuit right there. No current can flow. No current can flow in that circuit. If no current flows in that circuit, the voltage across that is I, the current, times 15 ohms, which is equal to 0 volts. Now your final answer for V1 has to be equal to your V1 prime plus your V1 double prime. Your V1 prime was 30 volts. Your V1 double prime was 0. 30 volts plus to minus. Now, that was a pretty simple problem, but sometimes these simple problems will allow you to get the skills you need to do the more involved ones. That's superposition. If you look at page 103, I have another example using superposition. It's an example in the book. Here's a circuit, and we want to calculate I1, I2, and I3 using superposition. So the first thing we do is redraw the circuit. Now I would encourage you to do this neatly. Notice how I'm working these out. I'm trying to be as neat as possible, and that's the way I'd like you to do the homework, and that's the way I'd like you to do the exams. First thing I want to do, and I don't care which one of these you pick, I picked the 35 volt source and I reduced the 40 volt source to 0. How do you reduce a 40 volt? How do you reduce this voltage source to 0? You short it. And I can clearly see this current here, I1, goes in that direction. I'm going to call that I1 prime. This current here, which I'm going to call I2 prime, I didn't label it. It clearly goes in that direction. And this here is going to be the I3 prime. Notice I'm getting the directions from up here. I just assign directions up here arbitrarily. And then I come down here, and using this simple circuit, you calculate I1 prime, which is this current here. You calculate I2 prime, which is this current here. And you calculate I3 prime, which is the current through this 2 ohm resistor. I didn't show you the calculations, but this is a pretty simple circuit here. We did this in chapter 2. But I want you to calculate the currents. Now that's only part of the problem. Because now what we have is we have another circuit to consider, which is with the 40 volt source. So what you need to do is you need to redraw the circuit, and that's what I did down here. I reduced the 35 volt source to 0. If there's a current source, we open it. It's a voltage source, we short it. And now I have another circuit, and I can clearly see the directions the currents are going to go here. They're going to flow in that direction, they're going to flow in this direction, and they're going to flow in that direction. So I calculate I1 double prime, which is this current. And I get 3.08 amperes. And I show the directions here on these currents because you have to add them up algebraically when you get through here with these. So I show them with these directions here. You could look at the individual circuits, but it's easier just to show direction. I2, which is this current right here, I calculate it, and it's flowing up or over, whichever way you want to show that. And I3 double prime was the current here flowing down, which is this value. These are the currents due to the 35 volt source. These are the currents due to the 40 volt source using two simple circuits. Now we algebraically sum the currents in each branch. You look at the branch I1, you look at these two currents. I1 is equal to I1 prime plus I1 double prime. Which one's the greater current? Well, the I1 prime is. It's going to be the actual direction of current. You take the I1 prime minus the I1 double prime, you get 5 amps. Let's take a look at that real quick here to make sure we got the right direction here on that. We got I1 prime up here as 8.08 amperes. We got I1 double prime is 3.08 amps flowing in this direction. So clearly I got this in the wrong direction here. So make sure you change that in your notes. That should be flowing in that direction. I2, let's take our I2 prime and I2 double prime. Okay, and that's this current out here. Clearly you can see that I2 double prime is greater. And I do that and I show this going in right to left up here, but it's the current. You can show it the current here, you can show it as the current going up or the current right to left. So that's okay, showing that convention right to left. I was okay there. And down here for I3 is going to be I3 prime plus I3 double prime. The largest current is the I3 prime, so I start with it minus, and let's see what happens here. I3 prime is 4.5 amps flowing down. I3 double prime is 4.61 flowing down, so they add to 10 amperes. So there's my 3 answers using superposition. Now what I would strongly recommend is you do a quick check using Kirchhoff's current law to see if you got these right. I would pick this node up here, and I would say I3 is leaving this node up here, and it's 10 amperes. So I1 and I2 better be entering the node. Well, here's I1 entering the node left to right. It's 5 amperes. And I2 is also entering the node right to left. And they sum the 5 and the 5 to give you the 10. So a quick check by Kirchhoff's current law, and you don't have to write in a quick check here by Kirchhoff's current law, and you do not have to write the equation. Just do it in your head. You can move on to the next problem because you're sure you got these right. On page 104, there's another example, example 3. Here's a circuit. I want you to find the current through the 6 ohm resistor and check your answer by your own method. So you could check your answer any way you want to check the answer, but I want you to go ahead and find your current here. Let's assign this like that. And let's call that just I. You're just going to find I right there. Oops. Not that current. Not that current. We're going to find this current right here. We're going to call that I6 ohm, matter of fact. Find the current through this 6 ohm resistor here using superposition. Now remember what you're going to have to do. I'd take this first and find I6 ohm prime by reducing this to 0, and then go back and use this current source and find I6 ohm double prime by reducing this to 0. Add them up algebraically. I think you can see here they're going to add. This is going to produce a current down, and this is going to produce a current down. So you can use common sense in this case and see that they're both going to presume assign a current from plus to minus from top to bottom. The answer is 8 amperes. Make sure you can do this simple problem so you can do the more advanced problems. In your book, there's an example 4 on page number, let's see, example 4, example 5.3, and this is what it looks like. So just look over. This is another good example, a basic example, and they calculate. They want you to find V out here in this circuit. And they want you to use superposition. So they go through and they give you an analysis using their techniques, and they calculate it to be 6 volts. As a real quick reminder, we use superposition to analyze some of the op-amp circuits. So if you look back at the end of chapter 4, let's see if I could find that real quick and throw that up. Yeah, we did these problems right here, and we did them. We used superposition to find this problem right here, to find the answer right here. Find the output V out prime due to this source, reduce this to 0, and then find output V out double prime due to that, with that reduced to 0, and add the outputs up algebraically. The V out would be equal to the algebraic sum of V out prime and V out double prime. You'll get minus 5 volts. Same thing down here. Use superposition 3 times. Do a little chicken scratching if you have to, but you should be able to do this in your head, and you should be able to do this in your head. The author picks easy resistance values for gain. Just remember, some are positive gains, some are negative gains, depending upon if it's an inverting amplifier or a non-inverting amplifier. You should get 18 volts for this one, for V out, using superposition. So on page 169 in this textbook. And that concludes the lecture on superposition.